Hi everyone, and welcome to Astro at Home, presented by Discover the Universe. As you guys are probably already familiar, we normally teach your teachers how to teach astronomy, but during this time when we're all learning from home, we're very happy to present programming for you guys directly on astronomy and a variety of topics. And before we get to our topic for today, just those regular reminders about respect in our chat. So we ask that you respect one another and you stay polite. We also request that you not spam the chats, which is sending several messages back to back, so it fills up the whole chat window. If you obey those rules, great. Send us as many questions as you'd like, and we'll get to them as soon as we can. In terms of if you break those rules, we'll delete your message or we'll put you in a timeout, which will keep you from using the chat for about 5 minutes. So just please stay polite. Today, I'm really excited to introduce to you Matthew Bamsey, who works for the Canadian Space Agency, and he's going to be talking to us about growing food for space exploration. So Matthew, I would like to welcome you to present.
Thanks, Lindsay. Very happy to be here, actually. And yeah, I think like everybody, looking forward to the weekend. I think I'm just hoping everybody's healthy at home. Your families are doing well. I think there's a lot that we can learn being forced at home like this, you know, somewhat similar to what astronauts have to deal with on their missions. And we're going to talk about actually how astronauts survive on these long duration missions to space. And in particular, the opportunity to grow plants in space. And, you know, yes, we're locked at home, but this is a perfect opportunity for us to learn some new things. And I'm excited to share a little bit about that with you today. My background is primarily engineering and looking at how we can support human missions to space, but I also became very fascinated about the opportunity of using plants. And we're going to talk a little bit about how we can use plants to keep astronauts alive at space. I'm very fortunate to work for the Canadian Space Agency. I think in Canada, we're very lucky to have a space agency. Not every country has a space agency, and the things that Canada does are pretty amazing in the space world. And we have an astronaut corps, which as well, not every country has an astronaut corps. This is a picture of the Canadian Space Agency headquarters near Montreal. My role at the space agency now, and I'm recently returned, we're going to talk a little bit about opportunities for scientists and engineers to travel, and that how amazing it is in terms of opportunities to really see the world as a scientist or engineer, and how it can be a pretty cool career. You know, my work with this Canadian Space Agency and some of the other space agencies have been to travel, for example, to the north, near the North Pole, to the South Pole, and to do some amazing other opportunities that a scientist can do out there, such as fly in an aircraft called the Vomit Comet, or fly parabolas in an airplane to study how plants respond. And our group at the Canadian Space Agency, the Space Exploration Department, is really looking at planning missions and sending robots to the moon and Mars, looking at how we can use telescopes in space to study the universe, so space astronomy, and finally, human space flight, so sending astronauts to space. And this is our headquarters near Montreal. As said, this is really the headquarters of human space flight right now in space. There are currently 3 astronauts living on the International Space Station. They're going to be joined by 2 additional astronauts next week, which is a really exciting week because it's going to be SpaceX's first crewed flight. So NASA's launching 2 astronauts to the space station on that flight with a crewed Dragon vehicle. And really what's exciting about the space station is, you know, this is a facility that now has been crewed for 2 decades, essentially. And astronauts will go and spend 6 months typically at a time on the space station. And their typical day is just like essentially a typical day here on Earth. So they're going to be working hard. They're going to be repairing things on board the space station. They're going to be doing science. They're going to be doing their workouts. And we'll talk a little bit about that as well to stay physically fit in space. And they also have free time like we do here on Earth. So although their everyday activities are similar to what we have here on Earth, the space environment and the microgravity environment really makes some of these activities a little bit different in space than they are on Earth, for example. So the famous space toilet. I know that's a very important topic, of course. I've got two exciting pictures of a space toilet here. The one is an actual space toilet that's used on the International Space Station. Russia built the two space toilets that are in the International Space Station. But I want to focus your attention to the right-hand side, and that's actually a test toilet on the ground so astronauts can practice to use the toilet in space. And this was actually the toilet that was used on the space shuttle. And can anybody pick out a few of the details as to why or how this toilet looks different than maybe a toilet we will use on Earth? You know, take a look at that picture. Let me know. Yeah, what do you think are some differences? I think one that stands out from the get-go is these red clips there. These attachment points for the actual astronaut, because again, they're in microgravity. Things sort of float around in space, including the actual astronauts. So you got to keep them on the toilet while they do their business. That's an important aspect. And a similar aspect is to make sure that we keep these waste products from the astronaut going into the right place. So this toilet actually has a suction, almost like a vacuum cleaner, that's going to pull the waste away from the astronaut's body. We don't want any UFOs flying around in the crew cabin where the astronauts are having their meals, for example. So that's a very important aspect. So even the process of going to the bathroom in space is different than it is here on Earth, as is brushing your teeth. And another important aspect of this practice toilet is that astronauts need to be precise. So this is an actual practice toilet that has a camera in there so they can make sure that they're very well lined up. We don't want any problems on orbit. The other thing is these waste products, once they're prepared, once they are collected, are actually put into an uncrewed vehicle that's going to burn up in the atmosphere. So this summer, if the whole COVID-19 situation, reduces, and you're at your cottage, you're out in the countryside somewhere, and you see a shooting star moving across the sky, it actually could be astronaut waste burning up in the atmosphere. So just be aware of that as well. Another activity that is a little bit different in space is showering. Obviously, since astronauts are spending 6 months on the International Space Station, they have to still clean themselves, but there is no shower on the space station. So the images we see here are actually a shower from the Skylab station. That was a United States space station in the 70s. And on the left, we see actually Pete Conrad, a US astronaut who later who actually had walked on the moon previous to that, in the shower. And the reason why the shower did not get transferred over to the International Space Station, and again, it's called international because there's many now countries working on it: Canada, United States, Japan, Russia, and many countries. The reason why there is no shower on the International Space Station is it actually took the astronauts typically about 2 hours to set up this shower so that they could clean themselves, essentially. And the other issue is that when you have water floating around in the space station, there's a lot of electronics, and as you know, water and electronics do not mix so well. So showering on orbit is quite different as well. The other things that do happen to astronauts, so yes, the microgravity environment where things float and everything else influences and affects how astronauts do things like brushing your teeth, cleaning themselves, or using the toilet. But the space environment also affects the astronauts' bodies themselves. So over long missions, muscles will get weaker, bones will get weaker. And those two reasons are one reason why astronauts typically have about 2 to 3 hours dedicated in their schedule every day just for exercise. So you've probably seen images of astronauts on a special treadmill or an exercise bike, and there's even some weight machines up there that astronauts can use as well. Other things that are not necessarily so great for astronauts in space is radiation. On the International Space Station, which is only 400 kilometers above the Earth, the astronauts are reasonably well protected by the Earth's magnetic field. But as our astronauts go further and further away from Earth, radiation will become an even bigger issue. So all of these things need to be studied to make sure our astronauts are safe when we're sending them, for example, on a 2.5-year mission to Mars, for example. So besides the effect on the body, what else do you think actual astronauts need to survive in space? So we talked a little bit about the arrow on the right-hand side, that yes, astronauts will produce waste products in space. We talked about the space toilet, but what about the arrow on the left-hand side of that screen? What does an astronaut need to survive in space, for example? And it's not too much different than what we as people need on Earth, actually. And there's, for people who design life support systems, or how we keep astronauts alive in space, there's 3 main things that have to be provided to those astronauts. And again, similar to what we have here on Earth, there's clean water, for example. Astronauts need to drink water. Astronauts use water in preparing their food and for cleaning, for example. There's air or oxygen, for example, that's required by the astronauts to survive. And then there's food. All 3 of those are definitely required for people to survive in space. And the longer and longer the missions get, the more of those things will need to be brought with you from Earth, typically, unless there's a way to recycle some of those things. On the food aspect, currently astronaut food, after a few weeks, because during launch, they can bring up some fresh food with them on their missions, for example. But after a few weeks, the fresh food typically runs out, and astronauts are left with food such as what you see on the right-hand side of your screen. Typically, the food has been dehydrated, for example, or is made so that it can be stored for a long period of time in the cupboards or in storage on the space station before it is used. So, for example, on the right-hand side, the food in the plastic packs, the astronauts will add hot water to that food and be able to eat it afterwards. On the left-hand side, you see a group of 6 astronauts enjoying their time on space station. There is one Canadian in that picture. For those of you that can pick him out, please do so in the chat. That'd be great. And we'll jump on. Astronauts are quite happy with their food right now, but there's still some possible improvements to make food even more enjoyable when we're talking about long missions to the moon and Mars, for example. And one opportunity is to actually grow plants in space to produce fresh food for those astronauts. Like every night, I hope on your dinner plate, you have some fresh vegetables or fruit or something else that's fresh to eat. So being able to provide fresh food for astronauts is a very important aspect. And the other beautiful thing about plants is, as you know, with trees, they absorb what we breathe out as carbon, that we breathe out carbon dioxide as people. Trees will bring in the carbon dioxide and produce oxygen, which is what we need. And plants can also produce clean water for us. So they can do those 3 things, air, food, and water, for these long duration missions to space. The other question that is asked here, can plants actually make people happy? If you look at the picture here in the inside of the space station, we don't see a lot of green stuff, but it's pretty well proven that people enjoy nature. You know, that's one reason why we often will go out into our national parks or go to the park or have plants in our house or in school or in our workplace, for example. Plants can actually make people happy. Have some green stuff and actually work with some plants can probably help keep astronauts mentally fit and happy over these very long missions to space. So that's another reason why plants could be a useful benefit for these missions with astronauts to the moon and Mars. The other amazing thing is that the technology about how we can grow plants has really improved just over the past few years and decades, actually. So this is an image from the German Aerospace Center. So before I returned to the Canadian Space Agency, I was fortunate to work for the space agency in Germany. And we were growing plants without sunlight, without soil, and essentially in a laboratory beside a parking garage in the middle of the basement of our institute. And that's one of my colleagues there, Daniel, holding up a plant that was grown aeroponically, it's called. And aeroponics means you have your water and your nutrients and you just spray it on the roots. So those roots are hanging in the middle of the air, for example, and you're able to grow these plants without any soil or without any dirt, and grow them even faster than you can normally outside, which is amazing. And so these are the same technologies that are going to help us grow plants in space, special lights and special ways to be able to grow plants even more efficiently and grow even more vegetables even in a smaller amount of space, for example. And right now on the, this is David St. Jacques in his mission several months ago, a Canadian astronaut. In front of David, you can actually see two of the plant growth systems on the International Space Station. And like the past previous image where we saw that sort of pinkish, purplish light, that's can usually be a clue to you that there's actually plants probably going to grow in those little facilities there, because we use purple lights, or purple LEDs, they're called, a special type of light, because if you're actually to look outside or look at a green plant, the reason why that plant is actually green is because it's the light that the plant does not use. So it's actually, a plant is typically reflecting a lot of that green light to our eyes, and that's what we see as people, and that's why plants typically look green. They don't use the green light, but plants do use the red and blue light. So again, if we were looking at a rainbow, or you have a prism and light shining through it, you know, light's made of a number of different colors. Well, if you just want to grow plants without wasting any energy, then you can just shine this red and bluish light, which makes a purple light on them, which is pretty spectacular and even more energy efficient to grow plants in space. And so on this image, we see these very small plant growth systems, very too small to actually be able to produce enough food to keep the astronauts alive. These are very, very small. For us to actually start to really be able to contribute to the astronauts' diet, we need something a little bit bigger. And so we'll bring in the famous actor here, Matt Damon, and his movie, The Martian. For those that have seen this movie, Matt Damon survives on the surface of Mars to some degree because he was able to get this greenhouse going. And so for us to actually start to be able to grow enough plants for astronauts to keep them alive, to produce enough food for them, we need bigger greenhouses. And so to go from what we have on the International Space Station, something small, to something this big or even bigger, there is an ideal place to test these technologies on Earth before they go to space. And that's in, I guess, what you would call extreme environments on space. On Earth. So, and they may be similar to space in some way. And so oftentimes different space researchers or scientists or engineers will go to these environments on Earth that are typically a very cold or very extreme environment, where like temperature, but even more importantly, maybe is the remoteness of these places. You don't want to be able to just be able to go, if something breaks in your robot or your system, to be able to go to the hardware store and fix it right away. You want this to be similar to when astronauts are going to be on Mars eventually, whereas something breaks, essentially they're on their own. And so the Canadian Space Agency previously had a project in the far Arctic on an island called Devon Island. It's the largest uninhabited island in the world, so nobody lives there. It's quite close to the North Pole, so it can be very cold in the wintertime especially. And this is an image on the right-hand side of one of the research stations there. And on the far right, you see an actual greenhouse that the Canadian Space Agency and a few partners operated. And what we were trying to do with that greenhouse was reduce the amount of time astronauts would need to look after the plants. So yes, we probably want astronauts to take care of the plants because it helps them stay mentally healthy, as we said. But also, we probably don't want our astronauts spending 16 hours trying to keep their plants alive so that they can stay alive. Because when we send astronauts to the moon and Mars, we also want them to be out there doing science, to learn about Mars, to collect samples, for example, that they will bring back to Earth eventually. And so this greenhouse allowed us, because we were only on Devon Island, only on site for about 1 month, to get everything ready, to plant things, and then we'd let the system run by itself autonomously for the other 11 months of the year and try to grow the plants by communicating with the greenhouse via satellite. And interestingly, 1 year, a few months after we left, we received this webcam image from one of the cameras that we had outside the greenhouse, and we saw these tracks out and around the greenhouse. And as I said, Devon Island is the largest uninhabited island in the world. So what could be running around on this island? I think everybody might have a guess. In the Canadian Arctic, there's one creature, one animal that's very popular. It is a polar bear. And in fact, we had some experts take a look at those pictures. They were definitely polar bear tracks. And after the dark season, we had a plane that flew over the greenhouse, and we actually saw this hole in the side of the greenhouse that the polar bear had actually made this hole in the greenhouse and got in the greenhouse and disrupted our experiment by knocking some of the plant trays on the ground. So if we were to have started our pump, all of the water would have been wasted. So I guess the main lesson to be learned on this this project is, in the Arctic, you got to watch out for polar bears. But the good thing is, on the moon and Mars, polar bears are not going to be an issue. So we're not going to be running into those same problems when we send these greenhouses eventually to the moon or Mars, which is a good thing. On the opposite end of the world, so we talked about a project in the Canadian Arctic. Another amazing place to test some technologies before they go to space is Antarctica, so at the South Pole. And I feel very fortunate as a Canadian to have had the chance to go to Antarctica. And this was during my time with the German Aerospace Center. Germany has an Antarctic station in Antarctica, and it's called Neumayer 3 station, and it's above the ice. It's about 75 meters long, and the amazing thing is that there's 10 people that stay over winter there. So 10 people that actually live on the Neumayer station for 13 months. So they have a bit of crossover with the next crew who is going to live there for 13 months. So 10 people is actually quite similar to what you could imagine for a mission, one of those sort of first missions to the moon and Mars. And these people are isolated for 9 months. There's no boat. There's no airplane that gets to the Neumayer station during those 9 months. And they also run out of fresh food soon after they arrive. A few months in, they might not have any of the fresh food left. And so actually having a greenhouse there was very beneficial. And you can just see how beautiful the station is and the environment, the Antarctic environment there. And we decided that we would build a greenhouse about 400 meters outside of the station. And so this would allow the people to have access to the fresh food throughout the year. And for us to get down to Antarctica, interestingly, although it's on Earth, it almost takes as long to get there as it does to get to the moon. So typically to get to the moon, when we've sent humans there, and you may know that there's been 12 people that have walked on the moon before, but countries are now going back to the moon. And we'll talk a little bit about that in a future slide, but it's a really exciting time for the space program. But to get to Antarctica, it actually took 3 days from me leaving home to actually get to the German Antarctic station. We flew on this amazing Russian airplane that brought some of the people down, and we had some of our hardware and greenhouse actually go down on an icebreaker, which is pretty neat. To give you a feeling what life is like in this Antarctic station, it's similar from the perspective that in space, and on the ground, you want to keep your researchers and the people that live there healthy. And so there's some exercise equipment here. You see some of it on the left-hand side. You want to keep them happy. So there's this room that's shown on the top right image, which is focused on, what people can do in their spare time. There's a nice coffee machine, foosball table, a pool table, for example, a place to watch movies. So after a long day of work, people can go and relax for a few minutes. And then I found this one very interesting as well, is how they make the water down there. So this is what's called a piston bully. That's essentially this tracked vehicle that pushes snow into a hole that opens up, that has a reservoir in it that just warms up the snow. And that's how the fresh water and the drinking water in the station is made at the Neumayer station, which is quite phenomenal. So what our project was working with many partners. And you can see actually a Canadian flag on there because we had some Canadian partners in this project as well. We built a greenhouse that is about 40 feet long. So if you're driving on the highway and you see a transport truck go by you, it's usually carrying a container that's about 40 feet long. And so what's nice about this is that this type of container is how goods and different products are shipped around the world. And so if we're building a greenhouse out of this type of shape and size, then we also know it can go and be sent to other places on Earth that it could be useful. And interestingly, it's very similar to the size of modules that might be sent to a future space station, or habitats that might be sent to the moon. So a very good practice ground so that we can learn how to do things in space. And this is a picture from inside of the greenhouse. You can see, again, we're trying to get as much green stuff, as many plants as possible out of the smallest amount of space. So we put plants on different levels, we put them really close together, and we have lights just over each of those plants to get as much out of there as possible. And you see a variety of different plants in there too, because you want the people living at the Antarctic station or future astronauts to have a variety of what they can eat as well. This picture put in there mainly just to prove that this was an actual greenhouse that we built in Antarctica. You see the Adelie penguins there. They're extremely curious little guys. They'll come running over to you. There are, of course, rules about wildlife in Antarctica not approaching them, but it was amazing to see them come up and see us. And you see the greenhouse with some of my colleagues behind as well. And so, that's really one thing that I want to get across to everybody today, is that, many people think of scientists and engineers as somebody working in a laboratory, for example, and maybe who doesn't see the sunlight because they're working in a lab all day. But both science and engineering can also give you this amazing opportunity to see the world, to work on amazing projects, to work internationally or across Canada. And it's a very exciting thing. And I think that's one thing that's pretty exciting about the space program itself, is that it's so many countries working together to accomplish these very exciting goals, whether it be the International Space Station or whether it be one of the next steps, which is the Lunar Gateway, a space station that's going to be around the moon. And Canada last year signed on and is building, or will be building, a arm that will be attached to Gateway that will also allow our astronauts eventually to fly to Gateway, and Canadian science and technology to be done on Gateway. So for sure, that's an exciting time. And right now, countries are planning to go back to the moon and use the moon really as this test bed for us to be able to eventually, soon after, send astronauts and more missions to Mars. And the technologies that we're learning about growing plants in space will be very important for those missions where we have astronauts living on the moon or Mars for long periods of time. But also the same things can help us here on Earth. We can reduce the amount of energy required by greenhouses, and we can help, for example, grow fresh food in places in Canada where right now there's not a whole lot of access to fresh food, for example, in some of our northern communities in Canada. And the Canadian Space Agency is working with some of our partners, such as the Agriculture Canada, National Research Council, and the Arctic Research Foundation on a project in Johaven in Nunavut to have a greenhouse there as a way to provide fresh food for the community, but also to test some of the things that might help us, for example, in space in the future. And the other amazing thing that I'll leave you with is that space can also help us with our agriculture in general, with satellites, taking pictures of the earth, and those can help our farmers grow plants more usefully, grow plants even better on the ground by using this satellite data. And I know one of my colleagues next week will be back at Astro at Home. Taryn Tomlinson will be presenting on how satellites can help us here on Earth. And we'll probably touch on some of the ways that they can also help us with agriculture in space. But I'll leave it at that. But I appreciate everybody listening in. And one thing from my perspective is space and human space flight is really my passion. And I, definitely, since you're here and participating in this today, that means you're out and exploring a few different things. And I really highly suggest that, you keep exploring what motivates you. And once you find that passion that excites you, your future job will also be your hobby and what makes you happy as well. So thanks very much for listening in.
Great. We have a few questions if you'd like to take those.
Please, Lindsay.
The first one is going back to the beginning of your presentation. What happens if the toilets break and where does the waste go?
But yes, you definitely don't, because a space capsule and the space station is very much sealed vessel. So, there's no way to escape there. The air in there can get pretty dirty if it's not cleaned out, for example. So you definitely don't want the toilets to be breaking. So that's one reason, and that's one reason in space in general, it's always good to have two of one thing. So that's why there's one reason why there's two toilets on the space station. In case one breaks, there's always a backup. And I think we want that for a lot of the other things we send to space. If something breaks, you want to have a backup.
Perfect. Somebody is very interested in carnivorous plants and is curious if they would be helpful in space in any way.
I think that's an exciting topic. I think for now, we're very much at the exploration phase, even about how we understand and see how plants change when they go to space. We don't know everything about how plants respond to being in space. We know we can grow plants pretty effectively and pretty well in space. We've been able to show that for a long time. I think there's some interesting opportunities with carnivorous plants. Who knows? Like, I know there's some pretty neat ideas out there also, because right now you saw the size of those plant growth chambers in space. They're very small.
Yeah.
But there's a few researchers that are proposing to grow trees in these small little containers. They're dwarf trees, but if we're able to grow these little small dwarf trees, then it also allows us to think about fruits that we wouldn't be able to grow in a greenhouse. So carnivorous plants could be coming after that as well.
Very cool. So they're asking, I don't know if this is accurate, but here's the question.
Please.
Why do astronauts only need vegetables? Why can't they eat meat?
That is a good question. So why actually, and very good one to confirm here. So astronauts do get a choice to pick their diet. So typically, in Houston, there's a team that focuses on what astronauts will eat, and the Canadian Space Agency has a couple of experts on the nutrition side and helping our Canadian astronauts pick what they would want to eat as well and bring up Canadian food. But astronauts really get a chance to select what they want. So right now, because all of the food is shipped up from Earth, there is meat that they can eat. And even if we're eventually to have a greenhouse that can feed our astronauts, I think there'll always be an opportunity for astronauts to have the foods that they want, and meat is probably on the list for some of those astronauts as well.
Yeah. Okay, cool. So we have a teacher watching with her classroom right now. She's actually also who's presenting on Monday for us.
Great.
And they're curious about, hold on, I can't read the whole question. They engineered their own classroom hydroponic system and garden, and they're curious about what sort of hydroponic system is used in space and why.
That is a great question, because when you have the word hydroponics, right away you think about water. And we talked a little bit about how the movement of water and making sure water is contained in space can be a challenge. You don't want space and electricity mixing, for example. And so you need to be very careful with how you deal with water. And right now in space, there's actually what are called pillows. So in those two little veggie units on board space station, they're actually sort of like a pillow in a plastic covering. And that is what holds the water and some sort of what is called a substrate, so that the roots can sort of move all in different directions in space. And so there's a lot of still challenges, and that is actually one of the bigger challenges, is making sure the roots have access to the water, but not too much, because if you also put too much water on the roots, you can hurt the plant as well. So big question, and that's great that your class is working on those issues.
Yeah, that's cool. Do plants grow faster in space, and do they taste any different if they're grown in space?
That is big for sure. There's a lot of different studies about understanding if the nutrition of these plants change, because it is a new environment for plants to grow in. In the very early days of trying to grow plants successfully in space, there were a lot of problems. And this comes back to the fact that the space stations are typically these closed environments where, if a gas is produced in that environment, it'll stay in that environment. So different chemicals can be given off by equipment in the space station, for example, and those might increase in their amounts or their concentration in the space station and actually start to affect plant growth. And that was shown a lot, is that some gases would increase in their concentration and really affect plant growth and decrease how much the plants were growing compared to what was being done on Earth. Because typically an experiment on Earth or in space will be done at the same time as one on Earth, so they can compare the two together. But now we're at a point where we can grow plants in space just as well as we can on Earth, and typically now better, because of the special lighting and because of how well we can control the environment in space as well now.
Great. Let's see, some of these questions you answered through your presentation. Oh, this is a little off topic, but I really like this. Do astronauts play video games in space?
Ooh, that's a tough one. I should know that answer. I don't know if there's a video game system up there, but I'm gonna guess that one or two have a hobby that have played some video games. I know that there was this big discussion about sort of real-time access to the internet for some astronauts, and for sure, you don't want astronauts downloading too much or uploading too much information to the space station, because it is all through communication satellites. So you definitely want to reduce the amount of video, right, and other data that's transferred. But astronauts now can for sure watch, big sporting events live, or download movies and be able to watch them. So I think the capacity is probably there for video games as well.
Yeah, very cool. So there is internet in space at this point, but it's slower than what we have here.
It can typically be slower, but nowadays the communication is actually so much better than at the start of the program, and so much better than what space stations were before. And we see today with the coronavirus how important these video links are, and that is definitely recognized for the astronauts that are on board space station, is being able to speak with their family and friends by video. And so there are very good video links now. So data is much less of a problem as it was before.
Very good to know for any of our little junior astronauts in the chat. They're very excited now to know that they'll be able to talk to their families, watch their sports, and play their video games while they're at work in space.
Good. Yeah, after a long day's work, you're allowed to relax like you wish. So
there you go. So at one point you had a picture, maybe this is our last question because I just noticed we're over time. At one point you had a picture and the astronauts were just sort of hanging out in clothing, and they were a little weirded out and were questioning how it is that they can be outside of their spacesuits inside the space station.
No, that's an important question. You're right. So inside the space station, the environment in there is similar to what you have in your house. So we always try to keep the temperature in and around what you have in your house, not too cold, not too hot, for example. The humidity, for example, is something similar. So inside the space station, it's very safe, very like your home. But you're right, as soon as astronauts need to go outside of the space station, then absolutely they need a space suit, because they cannot survive in that environment.
Yeah, Okay, thank you for that. So we did meet time. We went over a little bit just because we were excited to ask you some questions today, which I think is a good thing. But thank you so much for taking your time to hang out with us today and teach us a little bit more about your work and the future of food and space. I know the kids were really interested in food topics for sure. As soon as we started talking about food, I got a ton of emojis of junk food and little plants and
Okay.
stuff. It was great.
Very, very good. Well, thanks to you as well, Lindsay, and I wish everybody a great weekend. And once again, thanks for your time.
Yeah, thank you so much as well. Thanks everybody as well at home who joined us live today. We really appreciate you guys being here to our speakers. We're back on over the weekend, and on Monday we and robotics and how they link up to space. So I think my internet just said it's unstable, so maybe here, and we'll see you in a few days. Thanks guys. Bye.
Bye-bye.